Alright class, welcome back. I was going to do 8.3 in a couple of different videos, but we're going to just do it all in one video. So this video might be a little bit long, but not terrible. So basically what 8.3 is it's putting everything you've learned so far this semester together. We're going to be solving problems with radicals. We're going to be solving rational equations. We're going to be solving stuff that you factor, things that have rational exponents, negative exponents, and kind of look different. So basically this is just going to be like a conglomerate of all the different types of things we've seen and how to kind of approach that. So I'm going to talk strategy a lot during this lesson, and again what we're doing is we're solving equations that are quadratic in form. So they look somewhat like this. Now, when you're looking at this, you're like, that doesn't look like this to me. But it does, because this, if I took and I raised all this to the square, then this would just be x, and this would be x squared, and this would be 16. So it actually turns out to be in this format. You know, there's other things we could do with this too. Also here, what we would do is we'd find the LCD and eliminate. So it would end up looking like this. This one already looks like this, except for, you know, it's raised to the 4th power or the 2nd power or whatnot. This also looks like that because this is to the 2/3. This first term is still to the 1st power to the 2nd power. And we'll talk about how to deal with all of these. So again, we're going to go through each one of these problems, and this is kind of going to bring everything together from the entire semester. So I wanted you to have a snapshot of all the problems we're going to go through, and then I'm going to go through them one by one. All right, so starting with this first one, to solve this, we are going to first have to isolate this radical term. Okay, and the tools that we have right now, we've used factoring almost all semester, at least since chapter 5. So all the factoring things will apply here, and we'll check for factoring. We have just learned about the quadratic formula, and we definitely will want to use the quadratic formula. It works for any problem, but it's not always the easiest. Okay, so we only want to use it when it's easiest. And again, I'm gonna talk about how to tell when to use what. So we're going to use this when it's convenient for us. Okay, again, this is going to be strategy. And then we've also in 8.1, so this is 8.1, using the square root property, we said, hey, if something is squared, you can just take the square root of it. This is 8.2. This problem would be from chapter 7 here. And so, again, I'll kind of try to go through and say where stuff is from. Here we want to isolate the squared term, so I'm going to subtract x from both sides. I will get that negative square root of x is equal to negative x plus 4. I want to get rid of that negative, so I'm going to divide both sides of the equation by -1. That'll give me the square root of x, and then all over x minus, equal to x minus 4. A negative divided by a negative is a positive, and so on. So this -1 right here just changes both of these signs. So now that I've isolated this radical, I can square both sides. When I do that, remember what rules we're using here. We're using the square root of anything times by itself is just that thing. Okay, because it would be this, and then it would just be that. Okay, so this is just going to be x here. And over here, I'm going to have to FOIL this. Again, we're kind of going to pull out all the stops at this point. So everything we've learned so far throughout the semester. I'm going to FOIL here. I get x squared minus a 4x minus another 4x and plus a 16. This is a perfect square trinomial right here, because it's a perfect square trinomial. When you FOIL a binomial squared, you get a perfect square trinomial. Okay, so combining these, we get this negative x plus 16. But we still have this magic x over here that needs to be fixed. So you can see how, even though when it started out, it didn't look like this. It didn't look quadratic. But as you go through and start to solve it, it does. It comes down to this equation that if we started with this, you'd be like, oh yeah, totally quadratic. Okay, so it's in a quadratic form, or it leads to a quadratic equation, but you don't necessarily recognize it as such to begin with. Again, this is from chapter 7. You can review the videos. I think it's 7.6, how to solve radical equations, if you're curious about any of these steps or need to be refreshed there. Now, first thing I'm going to do, now that I've got it in this quadratic form, is I'm going to try factoring. If I can factor, that's going to make my life a lot easier. So factors of 16 are going to be 1 and 16, 2 and 8, and 4 and 4. And unfortunately, none of these factors are going to sum to a -9. Okay, that won't, and that won't. So I can't factor. So then I'm going to go to the quadratic formula. Okay, well, now that I've got it in this format, I can identify A, B, and C. A is going to be 1, B is going to be -9, and C is going to be 16. Remember, the quadratic formula is negative b, or the opposite of b, which would be 9 in this case, plus or minus the square root of b, which is -9 squared, minus 4 times a, times a, which in this case is 1, times c, which is 16, all over 2 times a. Okay, I'm going to work under the square root first. So -9 squared is going to give me 81. And 16 times 4 is a -64. So 81 minus 64 is going to give me square root of 17. This is a prime number, so it can't be simplified. I'm going to bring down the rest of this quadratic formula here. And since this can't be simplified and there's no common factors here, then this is the answer. Again, I had to use the quadratic formula here because I can't factor it. This polynomial was a prime polynomial. So, but again, my go-to is going to be, well, I'm going to say, hey, once I get it into this quadratic form, can I factor it? That's always going to be easier, in my opinion, than dealing with the quadratic formula. Some people love the quadratic formula, which is totally fine too. Also wanted to mention that here under the square root property, as part of it, we could use completing the square, which we have an entire video on completing the square from 8.1 as well. So we will probably do that in one of these problems. All right, so let's look at this rational expression now. We've got 5x over x plus 1 minus x plus 4 over x, and that's going to equal to 1 over x plus 1. So again, this is back from chapter 6. So this is chapter 6, solving rational equations. So you can review that video if you would like more depth on this. First thing we need to do here is identify the LCD. We're going to identify the LCD because we want to get rid of the fractions. This is already in factored form. This fraction has the x, and this fraction has the x plus 1. So this fraction does not have the x plus 1. So I need to multiply both the top and bottom by x plus 1. And I need to multiply this one by x. Now that they would all have the same denominator, so in other words, this LCD, or the common denominator, is this. I can clear the bottom. Remember, when we have all the same thing on the bottom, I can just say, well, that doesn't really exist. The other thing that I want to make sure we do here is we want to check and see what x can't be. Remember that x can't be anything that would make the denominator 0. So it can't be any number that would make division by 0. So in this case, if x was 0, then this denominator would be 0, and we can't have that. Here, if x was 1, Again, this was x plus 1. So if x was a negative 1, then this denominator would be 0. So we can't have x be a negative 1 either. This is really important to identify what x can't be. Okay, so now back to solving this equation. Again, when I'm looking at this problem, I'm thinking this is a fraction thing. This isn't a quadratic. But once we go through and clear out the rational expressions on the bottom, we can have what's left here. X times 5x is going to give us a 5x squared. This negative right here is really, really important. Everything that we get past here, we're going to need to change the signs for. But first, I'm just going to do the foiling as if I'm going to ignore that sign. So I'm going to FOIL that right over here. We're going to get x squared when we do the firsts. When we do the outers, we're going to get plus x, inners plus a 4x, and lasts plus 4. So this is x squared plus a 5x plus 4. But I'm subtracting that. So remember that when we subtract something, that negative sign dumps in here and changes the sign of everything. So I am going to get a negative x squared, because this will be negative. I'm going to get a negative 5x, and I'm going to get a negative 4. So that is what is on top of this fraction right here, accounting for this negative. Again, this changed the sign of every one of these. We have a negative x squared, a negative 5x, and a negative 4, which I just pulled right up here. And on the other side here, because this already had the denominator, this is just 1. Now I'm going to combine all of these and put it into this format, and you can see now, oh, it is starting to look like quadratic. So a 5x squared minus an x squared is going to give us a 4x squared minus, a 5x, and then I'm going to move that 1 over, and that's going to be a minus 5. Again, I'm going to set all this equal to 0, and my first move here is to see if I can factor it. There's no GCF here, and this is a 3-term polynomial with a coefficient greater than 1, so I'm going to try synthetic factoring. I get negative 20. Factors of negative 20 are 1 and 20, 2 and 10, and 4 and 5. None of these factors will sum to this negative 5. None of them. So I can't factor this. This would have been a prime polynomial, but now we have the quadratic formula that we can use. So again, try factoring first, can't factor it. Now I'm going to use the quadratic formula by identifying A, B, and C here. So this is my test, can't factor. All right, so A is going to be 4, B is going to be a negative 5, and C is also going to be negative 5. So plugging it into the quadratic formula here, we're going to do the opposite of B, which is going to be 5, plus or minus the square root of B, which is negative 5 squared, minus 4 times A, which is 4, times C, which is a negative 5. And that's all going to be over 2 times A, which is 4. Working under the square root here, again, methodically, we're just going to simplify this expression using order of operations. I'm going to work square root first. Exponents gives me the negative 5 times negative 5 is a 25. And then we have a negative 20 times 4, which is a positive 80. So this is going to give me a 105. We should definitely try to factor this 105, see if there's anything we can factor it down to. We know that it's divisible by 5. That's going to be 21, and that's going to be a 3 and a 7. And as you can see here, the prime factorization is 3 times 5 times 7. None of these are perfect squares, and none of them are duplicated. Remember, I need 2 of the same factor for 1 to come out. So there's nothing I can do to simplify the square root of 105. So I'm just going to leave it as the square root of 105. And we're going to bring down the 5 here, 5 plus or minus the square root of 105 all over 8. Again, I want to check the coefficient here, here, and here to see if they have something in common, and in this case, they don't. So this is, again, my 2 answers for x. One is 5 plus the square root of 105 over 8, and the other is 5 minus the square root of 105 over 8. So back to chapter 6. Again, this is a rational equation. And again, we're pulling everything together that we've learned so far. And I would highly encourage you, as I put these up, to pause the video and try them yourself before and see if you can get the answer. Something I want to point out, again, or remind you of here, is that you're going to get as many answers as the highest degree term. I didn't finish writing this. This is all equal to 0. You'll notice here that this is to the 4th. Now, it's still in this format, but I'm actually going to get 4 solutions here because I have a degree of 4. Well, when we factor, how does this change? Well, I don't care that this says 4 because I'm still going to say, well, what times what? This is a hippobutts. I'm going to say I've got W, but instead of it just being W here, each one of them needs a W squared, because W squared times W squared would give me this W to the 4th. So I'm looking at this middle term, and each one of the factors will match the power on the middle term. Okay, so now we're looking for factors of 36 that are going to sum to -5. So if I were to list the factors of -36, you know, you could start with 1 and 36 and 2 and 18 and blah, 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 but it's really quite straightforward here. We've got 9 and 4. The 9 is negative and the 4 is positive, because -9 times 4 is -36, and -9 plus 4 is -5. That's what we were looking for. We were looking for factors that sum to this middle term. So I'm going to have a -9 and a +4. Again, whether I put +4 here or the -9 here, it doesn't matter. The order doesn't matter because these terms are related through multiplication. So now, in our class, we call this checking for nesting. Because these are still, each one of these factors have a power of 2 on them, I need to say, hey, wait a second. Can I factor this further? In this case, I can. This is a difference of squares, and it is going to factor to W plus 3, W minus 3. Okay, so again, all this is equal to 0. And then this isn't working out so hot. So I can't actually factor this further. This is a sum of squares. So I'm just going to leave it. So these are my factors. I've factored completely. So some of these are going to be a combination of 2, which you can see here. All right, so factored completely. Now I'm going to set each factor equal to 0. So x plus 3 is equal to 0. Sorry, y plus 3. Y, geez, that is a w, guys. W plus 3 is equal to 0. W minus 3 is going to be equal to 0. And w squared plus 4 is going to be equal to 0. Okay, well, let's solve each one of these. So w is the value of -3. It's also the value of +3. And what about this one? Well, since this can't factor further, before we would say, this is prime and we can't really do anything with this. But now we have the square root property. I can subtract the 4 over and get w squared is equal to -4. Now this looks exactly like this format of the square root property, so I can get w by taking the square root of both sides. This says then that w is going to be equal to positive, negative, what? Well, since we have a negative under here, we're going to separate this out to a square root of -1 and a square root of 4. Square root of -1 is I, and the square root of 4 is 2. So this is going to be plus minus 2i. So again, when we first started, we said, hey, we're going to get 4 solutions here, and we have. The 4 solutions then are w is equal to -3, -2i, 3, and a positive 2i. All right, so those are our 4 solutions. Remember also that, no, I was going to say something else, but we don't need to think about that right now. Okay, so here's the 4 solutions that we would get. Again, even if this has a bigger exponent than 2, it's still quadratic in form, which is really important to recognize here. Okay, so let's look at our next problem. next problem is going to have rational exponents. Doesn't that make you feel like you're going to barf just a little? Just kidding. I love this stuff, if you can't tell. All right, so this is super exciting, and we're just going to use our good old knowledge. So let's pretend like this said p squared minus 7p plus 10. Forget about the fact that it has a rational exponent, because I know that freaks everybody out. Well, if I looked at this and be like, well, dude, this is already in quadratic form, and I can try factoring this. Let's see. Can I make factors? This is a hippobutts like we learned in class, and it's going to be a -2 and a -5. Again, a -2 times a -5 is a positive 10, and those sum to the middle terms. Hey, that wasn't hard. So I'm going to get a, how does this relate to this though? How is this one different? Well, it's going to factor down the exact same way. I'm going to have a -2 and a -5. What's going to be different is instead of it being just a p, like we have here, again, look, hey, it's whatever the power is on this middle term that is going to go into each factor, which in this case is 1/3. So I'm just going to put p to the 1/3 right here. So don't let these fractional exponents scare you. Just remember that it's whatever is right here in this middle term. Okay, now this might look kind of weird, but I'm going to now set each one of these factors to 0. So I've got p to the 1/3, or in other words, the 1/3. Remember that if we have anything and its exponent looks like this, then I can rewrite it as this. That's what I'm going to do here. I'm going to say, hey, p to the 1/3 is actually the same thing as the cubed root of p. Sweet. Okay, so I've got the cubed root of p minus 2, and that's going to be equal to 0 because I'm setting this factor equal to 0. And then I've got the cubed root of p right here. Wish I could write that better. Okay, cubed root of p right here minus 5, and I'm going to set that equal to 0. Now I'm going to proceed solving these problems. How to solve a radical equation is in chapter 7, solving radical equations, so you can review that video if you would like to review here. But I've got the cubed root of p, and that's going to be equal to 2, and the cubed root of p is going to be equal to 5. Well, what I'm going to do here is I'm going to raise these to the power of the index. So if I just cube this, then this is going to be just p. Whatever I do to one side of the equation, I have to do to the other. So I'm going to cube this and cube this. Sweet. So what do we get here? Well, we get then that p is 2 times 2 times 2, which is 8. And p is 5 times 5 times 5, which is 125. Cool. All right, so who knew? Again, this is what we started with. Whenever you see something that has fractional exponents or some kind of exponent that scares you, just rewrite it like this and factor it that way, and then when you get to the end, replace these factors. Some people call this U substitution. I didn't really teach U substitution for our class because I think it can be confusing. I think it's just easier to think, gosh, what is this middle term, and put it in there. So again, here we have a lot of mixture. We've got rational exponents, we've got radical equations. So we're just kind of putting all this stuff together. Next question we're going to do has a negative exponent. Again, don't let that negative exponent scare you. Just rewrite it as if it's a positive exponent, and then we'll see what happens to this later. Now, if I saw this problem, I'd be like, sweet, piece of cake. But I see this, and for some reason I panic. Well, I know the reason I'm panicking, because I'm like, oh my God, what is that? Right? But we're just going to factor this. This is another hippobutts. And we're just going to say, okay, we've got x minus 3, x plus 2. Well, the reason we have x minus 3 and plus 2 is because negative 3 times 2 is a negative 6, and negative 3 plus 2 is that negative 1. So fantastic. So let's do what we did last time and say, I know I've got a negative 3 and a positive 2, but what is the power of the x that goes in here? Well, this power right here is 1, and that's what I put here, and that's what I put here. This power is -1, so that's what I'm going to put here, and that's what I'm going to put here. And now we're going to use the rules of exponents to help us solve this equation. Remember that anything to the negative power is really 1 over that thing. Again, we're putting all of this stuff together. So this is really going to be a 1 over x is equal to 3 when I add the 3 to the other side. Let me rewrite this and do the full steps. Minus 3 is going to be equal to 0, and a 1 over x plus 2 is going to be equal to 0. All right, so just set this factor equal to 0 and this factor equal to 0. Again, to make this positive, we're just going to stick it down in the basement using this rule right here of exponents, the negative exponent rule. All right, so I'm going to add 3 to both sides here, and I'm going to subtract 2 from both sides here. So I get that 1 over x is 3, and 1 over x is -2. Sweet. Well, I don't want to know what 1 over x is. I want to know what x is. So I'm going to multiply both sides by x. The x's here will cancel. I'll get 1 is equal to 3x. The x's here will cancel. I'll get 1 is equal to a -2x. To solve this one for x, I'm going to divide by 3. So we get that x is equal to, right here, 1/3. And right here, we get that x is equal to a -1/2. Technically, we should write these the other way. The smaller numbers come first. Some people are really picky about that. Okay, so here's our 2 solutions for x. Fantastic. Hopefully that was pretty easy to follow, and we pulled up the rules that we were using. These rules of exponents are in chapter 5, and this factoring of a hippobutts is also in chapter 5. Let's do another one that is a little complicated here. This will be our last one, and we are rocking it, guys. You're doing great. Keep going. I am so proud of how well you've all done with learning this material, even though this is not the format that you feel like you learn best in. I totally understand that. So let's say that I have this equation, and this equation looks kind of crazy. But again, I'm going to substitute this term right here. It's weird. So I'm going to substitute it for just an x. So if this said x squared is equal to 9x minus 20, this wouldn't be so daunting. So forget about the fact that it says this, p plus 2 and p plus 2. Just pretend like it's an x. Well, I want to get this equal to 0, so I'm going to subtract the 9x and add the 20. The reason why I'm doing that is I want to keep this coefficient positive because that makes my life a lot easier. So instead of moving the x squared over here, I'm going to move these over there. So I would have x squared minus a 9x plus 20 is going to be equal to 0. Sweet. So if I wanted to factor this, again, this is another hippobutt. So even though this looks crazy, if you look at this hippobutt is just going to be x minus 5 and x minus 4, because -4 times 5 is 20, a positive 20, and -4 plus a -5 is a -9. All right, so now let's go back over here and substitute this. We know that this is going to break down to something minus 5 and something minus 4. Well, what is that something? Just like always, I'm going to dump whatever this is in here. This was x to the first, so this is going to be p plus 2 to the first power. Weird, but inside of here I'm going to have a p plus 2. Okay, p plus 2. Now, each of these can simplify further. This is a minus 5. This is not being multiplied. So what we're going to do here is set each one of these factors equal to 0. I'm going to come back over here just so we can see what I'm talking about. again, this wasn't the problem I was given. That's not a 5 either, it's a 4, okay. But I can see that x is equal to 5 and x is equal to 4. So if I substitute the value of x, which is p plus 2 over here, that's going to be equal to 5, and p plus 2 is going to be equal to 4. Again, all I did was set this factor equal to 0 and add the 5 over, set this factor equal to 0 and add the 5 over. So now you can see if you subtract another 2 here, we get that p is equal to 3, and if I subtract 2 here, we get that p is equal to 2. So our two answers here are 2 and 3. Sweet. You can plug those back in to see if they work, but that's a little too much work. So this is the end of this video. I tried to give an example of kind of every different type of thing you could see here. Sometimes we use factoring, sometimes we use a quadratic formula, and one time here we use the square root property. We're going to be doing a whole bunch more on completing the squares, so hang tight. Again, this is the only video for 8.3 for the whole section. So I know it's a little longer, but it should be good coverage of all of them, all of the objectives.